This is the Algebra 1 STAAR, Lesson 19, Meanings of Slopes and Intercepts. And in this lesson, we're going to be covering slope, y-intercept, x-intercept, and we're going to be addressing how to distinguish the variables, independent variables, and dependent variables. And then at the end, we're going to be having 4 problems that you can have a chance to test your understanding. Recall the slope of a line represents the rate of change in one quantity with respect to another. Meaning of slope in a real-world situation, the slope line will tell you about the rate of change the two quantities the graph represents. And as I mentioned in lesson 18, slope is the answer to the question, okay, how much does y, or the dependent variable, change when the independent variable x is increased by 1 or unit. And so what you can have is you can have the change in y over change in x. And we talked about that quite a bit in lesson 18. Okay, STAAR tip: because the slope is the rate of change, you can use it to identify the independent and dependent variables. For example, if the slope is in miles per hour, then you know that miles depends on hours. So if you have miles per hour, just how it's arranged would tell you this here hour is going to be your independent variable, and your miles is going to depend on the number of hours. Okay, hint: time is usually the independent okay, yes, there we go, spelling, variable. And sometimes instead of the word variable, you'll see the word quantity used instead. So just in case you should see that, quantity. Variable is what's going to be used most of the time. And so using this rate of change, the number of miles you travel, if you're traveling 60 miles an hour, will depend on how many hours you travel at that rate. So if you travel 2 hours at 60 miles per hour, you'll travel 120 miles. Okay, example 1. Alejandro is stuffing envelopes for a political campaign. On Tuesday, he stuffed 4,800 envelopes in 4 hours. On Wednesday, he stuffed 6,000 envelopes in 5 hours. Draw a graph showing the relationship between the number of envelopes stuffed and time, and find its slope. Describe the meaning of the slope of your graph. In the situation above, the number of envelopes Alejandro can stuff depends on the time. So it says put the dependent variable, or the number of envelopes, along the y-axis. Okay. And put the independent variable and I think they're using altitude in feet, so this graph is not perfectly thing. This should not be This should be number of envelopes. Okay. I didn't proofread this exercise, nor did I come up with it. But you see that time, as I mentioned back here, is going to be your independent variable, which represents itself usually along the horizontal or x-axis. And so another thing we did in lesson 18 is I showed you this little format here. You can just make a table XY and put the points here in the table. You have 4, comma 4800. Okay, and then we have in 5 hours you'll have 6,000. And so if you subtract 6,000 minus 4,800, you'll get 1,200. And on the left side, you'll have 5 minus 4 is 1. So, yes, slope is the answer to the question. How much does this dependent quantity change when x is increased by 1? Next, the quick check 1. 1A, Andrew can type 400 words in 5 minutes. He can type 1,200 words in 15 minutes. Draw a graph representing a situation, then find the slope and explain what it means. What I'm going to do is write this down here to leave room. And so as a graph, okay, draw a graph. Well, here we draw an XY axis. XY, and we know that time is going to be our independent quantity, so 5, 10, 15. So we'll say this is going to be 5, 10, 15, and we're going to say this here, this quantity is minutes, abbreviated MIN. And this right here on the y-axis, we'll say these are words. Okay, words typed, and we'll say this is going to be our 400 here, and then up here we'll say this is 1,200. And so in 5 minutes he's typed 400 words. In 15 minutes he's typed 1,200 words. And so draw a graph representing the situation. I think it's going to be a direct variation. It's going to be something like this. Okay, this purple line. Then find the slope, explain what it means. Well, similar to how we've done here, lesson 19 and also previous lesson 18. We're just going to put the 2 points here. We have 5 minutes. He's typed 400 words. That's 1 point. And then we have after 15 minutes, he's typed 1,200 words. And then if we just subtract here, we're going to get 1,200 minus 400 on the right side, which is 800. And on the left side, we have 15 minus 5, which is 10. So our rate of change is going to be 800, and our units will be words divided by 10 minutes. And if we simplify this, we're going to have 800 divided by 10 is going to be 80 words per minute. Just W/M. Okay. So it means that for every minute that Andrew types, he will, on average, he will type 80 words. It doesn't say on average, it's actually what it is, if this is the exact relation. 1B, find the slope of the line at the right and describe its meaning. Well, this kind of recalls lesson 18, and if you pick out 2 points, this origin, we have a point at 0, 0, so this is a direct variation. And also at this point here, looks like that's right here, or let's go up here to this one. We have input value of 7 between 6 and 8, so 7, and then we have an output value of 5. Okay, so to find the slope, we would go ahead and put in, I'm not giving a lot of room here, xy, we have 0, 0, and down here we have 7, 5. So on the right side we have a change of 5 for over 7 days, increase of 5 over 7 days. So m equals 5 over 7, and it's going to be apples eaten per day, right? So it'll be apples per day eaten. Okay, next, meaning of intercepts. The y-intercept function is the y-coordinate of the point where the graph function intersects the y-axis given when the value of independent variable x is equal to 0. The x-intercept of function is the x-coordinate of the point at where the graph function intersects the x-axis when the value of the dependent variable y is equal to 0. So you have kind of a relationship between when a variable is equal to 0 and its opposite axis. Let's go ahead and look at this. Star tip, the intercepts cannot be clearly seen from the graph, or if just an equation is given, you can use the equation to find the x and y intercepts. And this is what I call the intercept method. You can find 2 intercepts. And they give the example, the equation y equals negative 1/2 x plus 40. Well, in the intercept method, what you do is to find the x-intercept, we're going to set our y value equal to 0. And when we do that, we get 0 equals negative 1/2 x plus 40. And then if we subtract 40 from both sides of this equation, we have negative 40 equals negative 1/2 x. And then to solve for x, we're going to multiply both sides by its multiplicative inverse, which instead of to cancel out negative 1/2, we're going to multiply by negative 2 over 1. And then over here on the left, also the same thing. Multiply by negative 2 over 1, which is the same as multiplying by negative 2. And so what we have left is x equals negative 2 times negative 40, so we'll have 80. So this is our x-intercept. And I'll just say x-intercept. Now what I do in my classes, I teach people that you can cover up you can cover up this y. Now we're going to go ahead and find the y-intercept. And to find the y-intercept, we're going to take that same equation, y equals negative 1/2 x plus 40. We're going to set the x value equal to 0, and so setting this equal to 0, what we're left with is y equals 40, and so this is going to be our y-intercept. And what that means is you can use this to draw a graph quite easily, because if you just have You know an x-intercept, you know a y-intercept, so we can just take so our x-intercept is over here at 80. Our y-intercept is up here at 40. And so our line is just connecting the points across the intercept like this. So you can graph using an x and y-intercept. Intercept method, very useful. Next, example 2. At the ending of each school year, Principal Sal stocks the teacher supply closet with new erasers. And I think this is the same equation we were given last time. The line crosses the x-axis, and you look back here, that's even that same equation, and you see a similar sketch. And I used the intercept method to get that. So you have the point here, 80, 0 is our x-intercept, and 0, 40 is our y-intercept. And we draw a line connecting those two. All right, quick check 2. The graph to the right represents the relationship between time and temperature of a solution during chemical reaction. Find the x and y-intercepts and explain what they mean in the situation. Well, this is our x-intercept right here that I'm pointing to, and that's the point 0, -4. And then our x-intercept is between 4 and 6. That's going to be 5, 0. And what do they mean in the situation? Well, what it means is at time, this one right here, the y-intercept, I'll just y-int, of -4 means that at time equals 0, or starting time, okay, temperature equals -4 degrees Celsius. Okay, and then for the x-intercept, of 5 means that the temperature is equal to 0 degrees Celsius at or after five minutes. Okay, so those are the meanings. All right, 2b, the equation t equals -4x plus 100 represents relationships in total score on the quiz t, and the questions counted incorrect x. And so t is going to be our dependent variable, and then x is going to be our independent variable. Okay, find the intercepts. Well, the intercepts we can set if we have t equals -4x plus 100. If we go ahead and cross out this t, we're going to have, and just solve this equation, we're going to and subtract 100 from both sides. We're going to have negative 100 equals negative 4x. And if you divide by negative 4, you're going to get x is equal to 25. And that's going to be our x-intercept. Okay. Room is going to be a issue here. And then the next thing we're going to do is find, if we take this equation, t equals negative 4x plus 100. And in this case, if we cross out the negative 4x, we're going to have t equals 100, which is our y-intercept. Now, we realize the variable isn't y, but it means the same thing, and it's a dependent variable. And so if we just draw a little sketch of this, again, with the limited space we have here, we can put up on the t-axis here 100, and then more room here, t, we have 100, and along the x-axis we're going to have 25. And so we have this type of looking graph here, intercept method. Explain what they mean in the situation. So at, okay, this is going to be questions incorrect. So if we get our y, I'll say t-intercept of 100 means that 0 questions incorrect gives you a score of 100. And then your x-intercept of 25 means there are 25 questions. Which, if you get all of them incorrect, you'll get a score of 0. Okay? All right, next, the assessment here. I'm just going to, for these problems, just pause the video, work out the problem, then work it out to see if you turn on the video on and see if you got it right. Okay. The line segment of the graph below shows the wages earned by cashier, in which the following best describes the slope of the line segment. Well, we can just find 2 points there, I hope. And we're going to get close to it, I hope. Where is one? Right here. It's hard to get. You want to get on an exact grid mark someplace. And we don't have a lot of things. I don't see exact. I mean, where's the thing right? Because it looks like it's trending right above this 8. So it's going to be a little inexact here. So let's go up as far as we can. And at 32 hours, we're going to get a little over 200 here. It's not right at 200, it's a little over 200. And each of these are 25 apart. So I'm just going to have to guess. I'm going to say 210. Okay, so uh, what we have is a relationship between hours worked and just kind of writing out what that looks like here. XY, at 0 hours, we have 0 money earned. And that's another thing. Money is usually dependent and time independent. And then we have 32, comma, 210. So we have 210 on the right divided by 32. And so if we just take our M, our earning rate per hour is going to be 210 divided by 32. And again, since we didn't get right on a line, that's not going to be exactly right. So that 210 divided by 2 is going to be 105. And then 32 divided by 2 is 16. So we can just use our calculator or resort to a long division, which I'm going to do here. We have 16, 105. So 16 will go in 105. How many times? Well, I trust it's going to be 6. And then 6 times 6 is 36. And 6 times 1 plus it's going to be 9. And so we have 105 minus 96, or 9. And we have 16 divided by 90, which is going to be approximately 5 or so. Well, it's not one of these answers exactly. Probably the best answer here is going to be B. And we didn't get this exactly right because we just couldn't get exactly on a grid here to get a precise answer, but given the answers we were given, B has to be correct. 2, the graph shows the height of the candle as it burns. Which the following best describes the y-intercept? The y-intercept is going to be right here, 16. It's going to be the height of the candle. Of 16 inches. And that's going to be it. That's the height of the candle before it burned, 16 inches. Okay, next, 3. The graph shows the altitude of a car as the driver descends a mountain. What is the meaning of the x-intercept? Well, the x-intercept is that's where y equals 0, right? So this will be at x equals 6 hours. What is the elevation or altitude? Altitude is equal to 0. So yeah, reach the base of the mountain after 6 hours. This will be the altitude of the mountain. Okay, so after 6 hours, we've reached the base right here, D. Next, 4. Some students collect the data below. They will graph the data. What will be the slope of the graph represent? Okay, so here you're given a month. And so if we really rewrote this thing in terms of just numbers, and we assume starting out, we did like an XY, the month of January will be time 0, but the temperature is 42, average temperature. February would be that be month 1, 56. March would be 2, would be 70. And then April would be 3, which would be 84. And then obviously on the left here, all these are going up by 1 each. And on the right, we have 56 minus 42, which is 14. We have for here 70 minus 56, which is 14. And we have 84 minus 70, which is 14. So what will the slope of the graph represent? Well, it would be the change in average temperature per month. X would represent the month. So change in average temperature per month. Answer choice G. Anyway, good luck on this, and hope you did okay and have learned something from this. Good luck. Keep on working.